Hey there, we are here to talk about writing the names of ionic formulas. So I have the formula right here. I need to write the name. This is luckily pretty easy for most of these. So we're going to run into a couple tricky ones and we'll see why. So this first one, zinc chloride. So the Zn, I looked up on the periodic table, I find that that is zinc. And the first element, the cation ion, the positive one, the metal, it stays the same. We don't have to do anything to it. It just stays zinc. Now the second one, chlorine, I'm going to drop the end and change it to IDE. So chlorine becomes chloride. So all of your ionic compounds are going to end in ide, IDE. And some of them are a little trickier to cut off that end than others. Because if we have nitrogen down here, that becomes nitride, not nitrogenide. So nitrogen becomes nitride, oxygen becomes oxide, and the trickiest one, I think, phosphorus becomes phosphide. So there's just a couple you might have to commit to memory, but other than that, it should be pretty simple. So this next one's one of those trickier ones. So we have gold here, AU. But if you look at your ion sheet, you're going to see that gold could occur in two different species. It could have a different charge. We need, for ones like that, where they could have two different charges, we need to indicate which species it is, which charge is it. And to do that, we need to figure out what charge it is. So I'm going to do a little bit of math here with this one. So sulfur here, that sulfide ion form, has a -2 charge. -2 times 3 would give me a total -6. So this side here has a total -6. We know this compound is neutral, so that means that this gold must have a total +6. I'll draw this out. I've got 3 -2s, -2, -2, -2. That's what the formula tells me. So I know I have 2 gold atoms, and together they must add up to -6. So that means each gold atom must have +3. +3 is kind of hard to see those pluses, so it's a little squished. So each gold atom must have a +3 charge. So I'd write this as gold, Roman numeral 3, sulfide. So again, it's only for those elements where they could have multiple charges, where we have multiple options. We need to indicate which species is it. So it's not for every metal, just for the ones that can have multiple charges. Let's actually go down to this one here because that is another one. It's mercury, where mercury can have multiple charges. So mercury stays the same. Oxygen has a -2 charge. So since there's only one of each, that means mercury must have a +2 charge to balance that out. So if we know oxygen has a -2 charge, again, go look that up on your periodic table. Mercury must have a +2 charge to balance that out. So I'd write mercury 2 oxide. These last two are ones with that nitrogen. So remember, the first element stays the same, lithium. Nitrogen can be a little bit tricky because we drop off that whole end and it becomes nitride. So drop off that whole end and we change it to nitride. And this last one, you guessed it, aluminum. Aluminum is always hard to spell. If you are in the UK, you would spell it aluminium, which is a little bit different. And on your IUPAC periodic tables, it is spelled aluminium. So sometimes you see it aluminum, sometimes you see it aluminium. Same thing. And again, that nitride. So notice how these all end in IDE. That's really important. And notice that sometimes we have a Roman numeral. So sometimes we have that Roman numeral. And that Roman numeral, here and here, that tells us that this metal can occur in multiple states. This is the one that we see right now. So this is the mercury 2 species. This is the gold 3 species because it could be Mercury 1, or it could be gold 2. We don't know unless we indicate it. So naming is a little bit easier than writing the formulas, but when you do run into those Roman numerals, they might trip you up a little bit. So just pay attention.